Hello everyone, welcome back. Um, this presentation deals with the module 3 of automobile engineering. It consists of the independent suspensions for front wheel and rear wheel and also air suspension system. Independent suspension. When a vehicle with rigid axle suspension encounters road irregularities, the axle tilts and the wheels no longer remain vertical. This causes the whole of the vehicle to tilt on one side. Such cases are not desirable. Apart from causing the rough ride, it also causes the wheel to wobble. The road adhesion is also decreased. To avoid this, wheels are sprung independently of each other so that the tilting of one does not affect the other. Other than this, there are several advantages over rigid axle type suspension, such as increased tire life. Lighter springs can be used in case of independent suspension. Soft springs improve ride comfort. Etc. Coming to the front wheel independent suspension systems, independent suspensions have become almost universal in the case of front axle due to the simplicity of construction of such a suspension system. Generally, there are five different types of independent suspension that are used for front axle. The first one being wishbone type or parallel link type. Second one is McPherson strut type. The third one is vertical guide type. The fourth one is trailing link type. And fifth one is swing half axle type. Now let us see one by one. The first one being wishbone type of suspension. The figure on the slide shows you the diagrammatic sketch of wishbone type suspension with coil springs. The use of coil springs in the front axle suspension of cars is now almost universal. It consists of the upper and lower wishbone arms pivoted to the frame member. The spring is placed in between the lower wishbone and the underside of the cross member. The vehicle weight is transmitted from the body and the cross member to the coil spring through which it goes to the lower wishbone member. A shock absorber is placed inside the coil spring and is attached to the cross member and the lower wishbone member. The wishbone arms are like letter V in shape, because of which the system is so called. Because of this V shape, the wishbone not only position the wheel and transmit the vehicle load to the spring, but also resist acceleration, braking and cornering forces. The upper arms are shorter in length than the lower arms. This helps to keep the wheel track constant, thereby avoiding the tire scrub, minimizing the tire wear. However, a small change in the camber angle does occur with such an arrangement. The wishbone type is the most popular independent suspension system. The second type of independent suspension system is McPherson strut type of suspension. The figure on the slide shows you the layout of McPherson strut type of suspension. A strut containing shock absorber and the spring carries also the stub axle on which the wheel is mounted. The wishbone is hinged to the cross member and positions the wheel as well as resists accelerating, braking and side forces. The camber also does not change when the wheel moves up and down. This type of suspension gives the maximum room for engine compartment and is therefore commonly used on the front wheel drive cars. This is claimed to provide increased road safety, improve ride comfort, light and self-stabilizing steering, which means that the car continues along its chosen line of travel when the brakes are applied, even though the road surface may vary. The next one is vertical guide suspension system. This type of suspension system is as shown in the slide. The kingpin is attached directly to the cross member of the frame. It can slide up and down corresponding to the up and down motion of the wheel, thus compressing or elongating the spring. In this, the track, wheelbase and wheel altitude remain unchanged, but the system is having a disadvantage of decreased stability, and this is rarely used. The fourth type of independent suspension is trailing link suspension. As shown in the figure, in this type of suspension, a coil spring is attached to the trailing link, which itself is attached to the shaft carrying the wheel hub. When the wheel moves up and down, it winds and unwinds the spring. A torsion bar has also been used in certain designs in place of coil spring. This system does maintain the camber and the wheel track constant. However, the distance between the front and the rear wheels does change. Difficulty to remedy this defect is the main reason for its very limited use in actual practice. The last type in front axle independent suspension is swinging half axle suspension. In this, wheels are mounted rigidly on the half axles, which are pivoted on their ends to the chassis member at the middle of the car. The main disadvantage of this system is that up and down movement of the wheel cause the camber angle to vary. Now moving on to the rear wheel independent suspension system. Though the rear wheels are not to be steered, yet there is a considerable difficulty in the rear wheel springing if the power has to be transmitted to the rear wheel. But even the rear wheel independent springing is coming into prominence because of its distinct advantages over the rigid axle type. The figure on the slide shows one method of rear wheel independent suspension. Universal couplings A and B keep the wheel vertical, while the sliding coupling C is required to maintain the wheel track constant, thereby avoiding the scrubbing of tires. This method has been used in the De Dion type of axle, which is shown in the next slide. The figure on the slide shows you the De Dion type of axle, where A and B represent the universal joint and C is the sliding joint. Another method of rear wheel independent suspension is the trailing link type. As you can see in the figure, in this trailing links are pivoted at right angles to the longitudinal axis of the car and carry the rear wheels at their end as shown. In the figure, A's and B's are the universal joints to keep the wheel track and the camber constant with up and down movement of the wheel. Yes, which are represented on the figure, are the coil springs with shock absorbers mounted concentrically within them. The trailing links hold the wheels firmly and also to sustain accelerating and braking forces. It is claimed that the combined metal rubber mounting responds softly on the straight roads and increase ride comfort. When cornering, they resist lateral force with a reliable stabilizing effect, even when the car is fully loaded. However, some drawbacks are the initial cost being very high, greater required greater maintenance required as number of bearings is larger, misalignment of steering geometry because of the wear of components, etc. The layout of an air suspension system has been shown in the slide. The four air springs, which may be either the bellows type or the piston type, are mounted on the same position where generally the coil springs are mounted. An air compressor takes the atmospheric air through a filter and compresses it to a pressure of about 240 megapascal, at which pressure in the air is in the accumulator tank is maintained, which is also provided with a safety relief valve. This high pressure air goes through the lift control valve and the leveling valve so that the air springs are blown. The lift control valve is operated manually by means of a handle on the control panel through a cable running from the valve to the handle. There are several advantages of air suspension over conventional metal springs, such as a variable space for wheel deflection is put to optimum use by virtue of an automatic control device. Because of the vehicle altitude is also constant, changes in the headlamp alignment due to varying loads are avoided. The spring rate varies much less between the laden and unladen conditions as compared to that of conventional steel springs. This reduces dynamic loading. It improves the standard of ride comfort and noise reduction attained with the air springs, reduce both driver and passenger fatigue. Generally, two types of air springs are used. The one is called as the bellows type and the second one is called as the piston type. This is about the suspension systems. If you have any queries regarding the contents of this presentation, do shoot a mail to hsrvcet@gmail.com. Thank you.